Hello everybody, we're going to talk about dimensional analysis, and when I teach students how to do these types of unit conversions, I try to break it into three different kinds of problems. So the first level is where you have a single dimension. So in this example, mass is what is being measured by both of these units. So we are changing one dimension, one step. So that's level one. This is the simplest type of question you will see in this class. So that's one dimension, one step. Okay? Now, if you were here in class with me, I would ask you to review the three parts of dimensional analysis. There are three steps that you need to do every time you do this, and the first one is to identify your pathway. So in this problem, it is asking you to convert kilograms into grams. That's the step that you need to complete. Video is right on top of the ID pathway. So A is ID pathway. Okay, so you got to go kilograms or grams. That's what the problem is asking. The second step is to identify any equalities. And in this case, we have to use the prefixes of the units to help us understand how many kilograms are equal to how many grams. So the equality that is relevant for us is that 1 kilogram is equal to 1,000 grams, because the word kilo means 1,000. So when I teach students to do this, I always ask them to put the 1 with the unit that has a prefix. So this kilo prefix means 1,000. We'll have other examples in the next problems. But the third step of dimensional analysis is to set up multiplication to cancel units. So the setup always starts with the number from the problem. So C, we'll put a little bit more space down here. So if you are starting with this number, 3.5 kilograms, really, dimensional analysis is all about multiplying fractions together. So if you make this number a fraction by putting it over 1, then the other conversion factors that you set up will also make sense. So in our first conversion, we have 3.5 kilograms. We need to switch kilograms into grams. And the way we do that is by setting it so that the units will cancel. So the 1 kilogram has to go on the bottom so that we can eliminate the kilograms. On the top, we're going to put the other part of the equality. 1,000 grams. So once you have this set up so that the units like kilograms cancel and you are left with only the units of grams, then you multiply across the top. So that's 3,500 grams. You multiply across the bottom, and 1 times 1 is just 1, and there are no units left. Okay, we're back. Sorry, I got unplugged. So once you have it set up where you multiply across the top and you multiply across the bottom, the only units that remain are grams in the numerator, and you can divide the top by the bottom. So in our case, 3,500 grams is equal to 3.5 kilograms. If you follow these three steps, no matter how complicated your conversion is, you'll be able to set it up so that you end with a number that is equal to the number you're trying to end with. Okay, let's look at another problem. I call these problems level 2 because sometimes your pathway is not a straight shot. If you looked on that little chart that's in your binder, I think it's on page 35, we don't have anything that tells us an equality from centimeters 2 kilometers. So the first step asks us to find a pathway. So the number that's given is centimeters, and it asks you to convert it into kilometers. But we don't have an equality for those 2 units. What you do have equalities for, though, is this middle step, centimeters to meters to kilometers. And sometimes you can use a little intermediate, like an intermediate stepping stone to get to the final version of what you're looking for. So if your pathway has to have 2 parts, that's fine. You should do that. But now that you have these 2 separate pieces, you have to find equalities for each of those conversions. So, like I was mentioning before, I always ask students to put the 1 with the prefix, because the word centi literally means 1/100th, 0, 1. So if you have 1 centimeter, that's 1/100th of a meter. And then the other conversion, I did it, this should have been in red, sorry. 1 centimeter is equal to 1/100th of a meter. And then conversely, if you need to find an equality between meters and kilometers, let's put the 1 with the prefix, because this prefix means 1,000. So if you have 1 kilometer, that means you have 1,000 meters. You could do it other ways. There are 100 centimeters in 1 meter. That's also true. But if you always put the 1 with the unit that has the prefix, you can use the name of the prefix to get your equality. Okay, well, the third step of our dimensional analysis is that you are supposed to multiply, set up this multiplication problem so that units cancel. And so since this problem starts with 6,275 centimeters, that's what we should start, 6,275 centimeters. We should start with that number. Okay, now since these are all fractions, it's useful if we put it over the number 1. So from here, we can use the 2 equalities that you just identified to begin canceling units. So here's the first conversion from centimeters to meters. We want centimeters to go on the bottom so that the units will cancel. All right, so if we're using this equality, the number 1 goes down here, and the 0.01 goes up here. Now, the next step is to convert from meters to kilometers. So now down here, we have meters. We need meters in the bottom and kilometers in the top. So this 1,000 meter goes down there. This 1 kilometer goes on top. Then, once you have set up your problem so that units cancel, so here we are canceling out meters, centimeters have already canceled. The only units left are kilometers. So now we can multiply across the top. So 6,275 times 0.01. If you did this on a calculator, you would get the number 62.75 kilometers. And then you multiply across the bottom. So 1 times 1,000 is 1,000. And there are no units left because the centimeters canceled and the meters canceled. So the only units that are present are the kilometers in the numerator, which is perfect because that's what we're trying to get to. And so, after you multiply across the top, then you multiply across the bottom, then you divide the top by the bottom. So if you did this on a calculator, you would get the number 0.06275 kilometers. Okay, that's level 2. Level 3 are the hardest ones. They have multiple dimensions. And sometimes these dimensions have multiple steps. But you can still follow your 3 steps for dimensional analysis by starting with the pathway. So this problem gives you kilometers per hour. That means it's in a fraction. You have a numerator and a denominator. That's what when you say per something means. It means that it is a ratio of two things. And in this case, we have a distance to a time. So this is the ratio of distance to time. We want to change kilometers into meters in the numerator. But in the denominator, we want to change hours into seconds. So those are the two separate dimensions that we are changing. We are changing a distance in the numerator, and we are changing a time in the denominator. So we need equalities for each of these things. And maybe you know equalities for each of them. So like, for example, if you know that 1 kilometer is 1,000 meters, that's great. You can use that one. Some people know this conversion, but it's okay if you want to go hours to minutes to seconds in the denominator. So you might have only one step in the numerator, but if you have 2 steps in the denominator, that's okay. So in 1 hour, there are 60 minutes. And in 1 minute, there are 60 seconds. So these are the 3, you might have 3 equalities. So in this case, these are the 3 equalities that we have if this is the pathway that we are going to use. So then the third step, I'm going to need my calculator for this one. The third step is to set up this problem so that the units cancel. So if you start with 9.75 kilometers, and now we're going to put it over 1 like we always do, except that this time the denominator has a unit. So we have kilometers in the numerator and hours in the denominator. The rest of this problem is just like we've done for all of these other examples. We want to set it up to cancel units. So if we start with this changing from kilometers into meters, we're going to put the 1,000 meters on top and the 1 kilometer on the bottom. In the second step, let's change the hours. So now we are trying to get rid of hours, which live in the denominator. So our problem has to put hours in the numerator so that these can cancel. So 1 hour is equal to 60 minutes. And then thirdly, we want minutes to cancel. So let's put 60, oops, that's not true, because here's the conversion we're using. We want 1 minute is over 60 seconds. Now, just analyze the units. Check to make sure that the units that you want to get rid of have been canceled. And so since we want to get rid of kilometers, there is a kilometer in the numerator and a kilometer in the denominator. Check. Next, hours are in the denominator, but we don't want them to be there. Hours should eliminate. And then secondly, minutes should eliminate because we want to end with seconds in the denominator. We want to end with meters in the numerator. So then you take your numerator and you multiply across the top. So 9.75 times 1,000 times 1,000 is 9,750. And then the only units on the top are meters. On the bottom, you have 1 hour times 1. Well, the hours are gone. So 1 times 60 times 60. And the units in the denominator that remain are seconds. So you end up with, if you did this on a calculator, you would end up with 3,600 seconds. So 9,750 is from the top, 3,600 is on the bottom. So you divide the top by the bottom. If you did this number on a calculator, you would get 2.7083 repeating. And let's check our significant figures. Since we started with 3 significant figures, we should round the third significant figure based on the digit that comes after. So 2.7083 will round to 2.71 meters per second. We did it. Good luck on your quiz. Let me know if you have any questions.